Welcome students. During this class, we will study about to find the density of an object by using Archimedes principle. During the previous class, we have studied about Archimedes principle. We have discussed about the ground force and we have seen what's the principle of flotation. At the end, we concluded that when the weight of the object is equal to the upthrust of the fluid displaced under water, then the object will float. If the weight of the object increases, then it will sink. But if the upthrust increases, then it will float. So here it is one of the application of uses of Archimedes principle. We can calculate the density of any object whose density is unknown. Suppose here, if you look at, first of all, this is an experimental setup, and most of the labs, the facilities available, and the people are asked to calculate the density of any object. Normally, they are given some spherical bob or any other type of the object. First of all, what they take the weight of the block in air before it is immersed inside or moved inside the liquid. The weight of the block is taken and say this weight is W1, and then it is allowed to sink. When it sinks down, then again the weight of the block is taken. Suppose this weight is W2. In air, the weight of the block will be more, but in water, the weight of the block will be less. Why? Because in air, the water molecules are upthrust of the water molecule is acting in upward direction opposite to the weight of the block, but it is very less as compared to the upthrust of the water. So that's why the weight of the block upthrust of the air molecule is less than the weight. So that's why the weight will be more. But if you move it inside a water, the water molecules are very much close to each other, and these water molecules will be displaced, and it will result in increase in the upthrust. So with the increase of the upthrust of the water molecule as compared to the air, the weight of the block will reduce. So this is the simplest type of experiment performed to calculate the density of any object. We will see the formula for calculation, but first of all, let's understand why the weight in air is more than the weight in water. The reason is very simple, because upthrust in case of the air is less, but upthrust in case of the water is more. So that's why in water, when it is immersed in water, the weight will be less, but when it is taken in the air, it will be more. So if it is W1, here it is W2. What's the buoyant force is equal to the weight of the water displaced water. This is the principle of the Archimedes principle. Then under this condition, what will be the result? This one. If you look at the ratio in the weight of the body, weights of a body with the equal volume of the liquid in the same is their densities. So how will you calculate then? This is the density of the object which is displaced, density of the object, and then if you look at the density of the liquid, that is rho, and the density of the weight W1. So here it is. What will be the formula then? D is equal to rho is equal to W1, weight of the object in air, divided by the loss of the weight in water, W1, minus here it is W2, multiplied by density of the water, it is almost 1. So if you put the values here, you will be getting the density of that object which was immersed inside the fluid, inside the liquid. First of all, we have taken the weight of the object in air, then we have moved that object in the water, then there will be loss of the weight. So the ratio between two, the weight of the object in air and the loss of the weight multiplied by the density of the water, that is basically density of the unknown object, unknown density of that object which you have immersed inside the liquid. So this is the formula to calculate. So here it is. If you look at this one is the density that is of unknown. This is the density of water. It does not mean any, it's make no difference. So thus finding the weight of the object in air, W1 in its weight in water, W2, we can calculate the density of the solid by using above equation. So this is the density of any object. Similar is the case here. This is, I have taken D instead of D, I have taken rho. You can also take this one D, and here it will be rho, the density of the water. So if you put the values here, you will be getting the density of any object which was not known to you. So this is the formula, this is the technique used to find out the density of any object. Which type of the method you will follow? You first of all, by following Archimedes principle, you will take the weight of the object in air, then you will take the object and you will note it down, say it is W1. Then you will take the object of, calculate the weight of the object when it is immersed in liquid before touching the bottom in the liquid. It is suspended in the liquid at a certain height inside, completely immersed. So its weight loss of the its weight is say W2, then the loss of weight will be W1 minus W2. In air it's more, in water it's less. So here it is. The density of that liquid is calculated by using formula weight of the object in air divided by loss of the weight when it is immersed in a fluid multiplied by the density of the water. Then you calculate the density of any object which is given to you in the lab. So most of the time you used to go in the lab to calculate the density of any object. It may be a brass bob, it may be iron, it may be a copper. Then you are asked to calculate the density of that box, and it is one of your experiment during the course of your study. So here it is. This is the final formula. You will put the value of the any object which you have taken in air. Then you will find the loss of the weight in water. You will multiply with the density that is the water, that is one, and then you will calculate the density of object which was done now. With this, our class ends. I hope you people have understood. Thank you very much for your patience.